In the previous lecture, you set up your Raspberry Pi 02W. It's ready to go and start working on the application. The other side of our full stack application is the remote node. Now with the remote node, you've got a lot of flexibility in terms of what microcontroller to use. You can use anything or any microcontroller, I should say, that is compatible with the Arduino IDE and the Arduino programming language and has an I2C interface available, plus a UART channel, a UART serial interface channel available, either hardware or software. The microcontroller that I decided to use is the ESP32 dev kit, simply because I have a lot of them. I have a lot of those boards. Price-wise, it's very attractive. The fact that it's got a lot of pins, a lot of channels, like 2 UART channels, for example, lots of communications options, is very attractive for this particular board. So I always keep a bunch of them available so that I can always do a quick prototype without having to dismantle a previous project. So you can choose any ESP32 development board that you have available. And I have just a generic low-cost ESP32 development kit that you can see here, already assembled with the hardware for the full stack application. Of course, since we'll be using the Arduino IDE to program the microcontroller, you can always go for an Arduino board. You can even use an Arduino UNO, for example, even though the Arduino UNO only has one serial interface, which is occupied by the USB port, which means that to use it for communications with the HC12 transceiver, you won't be able to use the USB port, but in that case, you can opt for software serial. So there's the software serial library, which converts any 2 digital pins into UART serial pins, so you can use independently of the USB port on the Arduino UNO. If you have an Arduino Mega, for example, it's another option. The Arduino Mega has a second independent hardware UART serial channel, so you can use that at the same time as you're using the USB port on the Arduino Mega 2560. So that's another option. But of course, it's a large board, so you have to deal with that as well. Other alternatives are microcontrollers in the MKR family. So one of those, for example, any of those would do. The thing to remember is that you do not need a Arduino microcontroller with Wi-Fi or other wireless capabilities like Bluetooth, because we'll be using the external HC12 module, which provides radio communications. So you could go for one of those devices without radio communications, just to save a bit of money in the microcontroller. You can invest that money on some other hardware. And the Nano family is also an option here. The Arduino Nano Every is actually a pretty good option, and the Arduino Nano very small and lower cost options for Arduino microcontrollers without Wi-Fi or Bluetooth capabilities. Again, remember, you don't need those. So make a choice of your microcontroller. If you want to follow exactly what I am doing in this course and follow exactly my examples, then you should go for an ESP32. If you are a little bit more flexible and you can compensate for the microcontroller that you want to use, an alternative microcontroller other than the ESP32, then by all means go with that option, go with the option that you prefer for the remote node. In the next lecture, which is the last lecture in this section, I'll show you how to connect your ESP32 to the Arduino IDE version 2, which is the editor that we'll be using for the remote node programming in this course.